Hey, this is a video for Diffusion 3. So go ahead, set up your Cornell notes. Remember to start a new entry for this video. Check out the essential vocabulary. We have the words osmosis, cell wall, and cytoplasm. So just to inform you that cells they're not 100% water. They have some other impurities in them, other minerals, a lot of salts and other molecules and compounds. Between 95 and 99% water. In our purposes today, or as we do this activity, we'll be just saying that cells are around 95% water, even though it does vary. So osmosis is defined as the movement of water across a semi-permeable membrane from areas of high water concentration to areas of low water concentration. Another way of saying it, osmosis is diffusion of water across a membrane. Diffusion of water. And remember, whenever there's diffusion, you're going from high to low. So in this case, osmosis, high water to low water. Now, if we had an isotonic solution, you don't have to know this word, but iso just means the same. So if we have a cell in a solution that has the same amount of water and, the same amount of impurities in it, there's going to be no high and no low. So there's going to be no net movement of water. The cell is going to remain the same. Now, if you put a cell into a hypotonic solution, this is an example of this would be distilled water, where it's just pure water, there's no other impurities in it. What's going to happen is you have high water outside, you have lower water inside the cell, so there's going to be movement of water inside the cell. Again, this happens in distilled water, but what's going to be an impact of this? Water's going to flow into the cell, and eventually there could be so much water flowing in that this cell could burst, and that would result in the death of this cell. So another example is a hypertonic solution, and that's when you have a low concentration of water and typically a high concentration of other impurities like salt or sugar or some other compounds. Hyper, you don't have to know it, but hyper just means high. So it would be a high salt concentration. Now, if you notice here, we have 95% water inside the cell and 70% water outside of the cell. So there's going to be a flow of water outside of the cell. And what's going to happen is the water is going to leave the cell, and this cell will start to shrivel or shrink. And this could also result in the death of the cell. Now, you could write this down into your notes. You don't have to sketch all of the details inside here, but I definitely would have this diagram inside your notes because it will come in handy as you're completing practice problems. Now, you did a lab, the diffusion through a membrane lab, where you looked at an onion cell. And the onion cell is good because you can see the cytoplasm. It's all nice and red. But you have the cell wall. And the cell wall, that is an organelle that provides rigid support around the outside of a plant cell. So the cell wall is kind of like a jar holding a balloon. And the jar prevents the balloon from getting damaged. Now, in this diffusion through a membrane lab, what you did is you observed the cytoplasm, the cell wall, and the cytoplasm, by definition, is an organelle that transports materials around the cell. And in layman's terms, it's literally just the liquid part of the cell. And if you were drawing a diagram, it's the part that doesn't have that, just the blank space. Even though it's not blank space, it's liquid and other chemicals inside. Now, in this diffusion through a membrane lab, you notice that the cell membrane, you can't really tell where the cell membrane and the cell wall differentiate. You couldn't tell when it was plumped up like this. This is more detail than you were able to see. Now, if you add salt water, what's going to happen is that cell wall is going to keep this cell the same size. But what happens is that water inside wants to leave the cell. Remember, it's 95% water on the inside, and we had about 70% water on the outside. So that water is all going to leave. When that water leaves, the cell membrane is going to shrivel. And eventually it's going to shrivel up into a little tiny little, like a balloon that's been deflated. Now, when you do this, you can actually see the cytoplasm is inside, and it is darker because it's more concentrated. And you can actually make out the cell membrane. The cell membrane is literally the outside of this little squiggly part. Sometimes they might show it as a round cytoplasm and cell membrane. Sometimes it might be shown squiggly. It depends on the diagram. It depends on really what kind of cell you're looking at. Now, if you add distilled water, if you add distilled water to this situation, the water is going to flow in because there's going to be higher water on the outside than there is on the inside. And if you add salt water, remember, it shrivels. So this is another good diagram to sketch and put into your notes. And it will definitely come into play because you will be answering questions on Part D of the Regents that are specifically related to this lab. One thing I want to say is the cell wall prevents plant cells from bursting when they go into distilled water or any form of purified water. I hope that this was informative. I would like you to complete your check for understanding. I thank you for your focus and your patience, and I will see you soon.